In this video, I want to demonstrate how to square up a block using a milling machine. When I say square up a block, when you say square, machinists think square, not necessarily dimensionally. I'm not worried about it being the same size both ways. What I'm looking for is having 90-degree corners. I want to verify that this is square to that. So I'm looking for perpendicularity, I guess, when I talk about squareness. So with this back jaw being square to the table, we know it's perpendicular, so we know this back jaw is square. We're going to use this back jaw to square up our part. So when I put parts in the vise, I want to make sure that the part is up against the back jaw. So the first step whenever you square up a block is to mill the first face. In order to face the part off, we're going to use a face mill. So this face mill, got carbide teeth in there. You see those gold teeth? Those are carbide. So carbide has a different cutting speed than high-speed steel. So for every cutter you use, you need to look at this chart. The materials we're using here today for this project is mild steel. So if you look on the chart under material, it says mild steel. That's the column or the row we're going to be working with. Now you have to look at what kind of cutter you're using. It could be high-speed steel, which is abbreviated HSS, or it could be carbide. So we're going to be looking for the carbide cutting speed for mild steel. So if I take the mild steel and I come over to carbide, it says there's a range of 250 to 700. Why is there a range? Well, it says here, use lower end of speed ranges for drilling, boring, and roughing cuts. What we're going to be doing when we square this up, it'll be kind of like a finishing process. So I'm going to go in the middle of this range. I'm not going to be on the low end or the high end. I'm going to use a number of, let's say, 400. So once you have that cutting speed, there's a formula here you have to use. In order to set the RPMs on your machine, you have to know the cutting speed, multiply it by 4, and divide it by the diameter of the cutter. So if our cutting speed is 400, you take 400 times 4 is 1600. And we have to know what size our cutter is. So if you measure the cutter actually measures about 2 inches on the face. So we're going to go 400 times 4, 1600 divided by 2 would be 800 RPMs. So we're going to put the cutter in the machine. Once again, make sure you line up the keyway with the key. Push the in button. And now your cutter is mounted inside the machine. So right now the machine's in neutral. I have to figure out if I want to be in high gear or low gear. The low gear ranges from 50 to 500. High gear goes from 500 to 3000 RPMs. So this reads RPMs. That's what we calculated off of our chart. So I need to set the machine up for 800 RPM. So that'll be in high range. So I'm going to put the gearbox in high, rotate the spindle, make sure it's in gear. Then you're going to switch it to high gear on the switch and start the spindle. Now while it's running, you adjust the variable speed. So you look inside the high gear window by the rabbit here, and you're going to turn this knob and get it down to 800 RPM. So now we have the machine set at 800 RPM. So when you go to mill this block, what we want to do is center the cutter over the material and feed across. Before I do that though, let's talk a little bit more about the process we're going to do here. What I'm going to demonstrate to you is squaring up the block using the 1, 2, 3 method. Right now, as it comes from the steel supplier, it's got rough corners. Nothing about it is really flat or square. Other than that, it looks like a square and it looks flat. But if you were to measure this, this is not precise at all. So to take rough materials and make them precise, you have to machine them. So I'm going to machine this one square. Then after I get this square, I want to make sure I put the square jaw up against, or the square surface up against the back jaw. Remember, this back jaw is the precise jaw on the vise. So after I machine that, I'm going to put that against the back jaw. I'm going to machine the second face. After I machine the second face, I'm going to flip it over and I'm going to keep it the solid surface, or the good machine surface against the back jaw, and machine the third side. So that's why they call it the 1, 2, 3 process. You're going to do the first step, the second, then you're going to flip it over and keep the first face against the back jaw and do the third side. So when using the vise as a work holding method, when you put your parts in a vise, sometimes your parts are too short. So if I put my part in the vise like that, it's below the top of the vise. So we have things called parallels. Now these are precise tools as well. Make sure they are free of burrs and that they are clean. So these parallels go underneath the part. So with the parallels in the vise, then I could put my part in the vise and it'll sit up from the bottom of the vise. It actually holds it above the top of the vise. So when you close the jaws are actually what holds the part tight. So make sure you tighten your vise. Put your part in, make sure the vise is clean, the part is clean, and you can tighten your vise. Now we have to center the table underneath the cutter. This cutter is big enough to do the whole width of the face. If not, you'd have to move over and take several passes. But we have a big enough cutter to do that. You need to raise the table up. Make sure your spindle is all the way up inside the head of the machine and locked. If you don't have that spindle locked when you start cutting, this is actually going to vibrate and come down on you, and it'll sink right into your material. So make sure that's all the way up and locked. So what I'm going to do here now, I have it centered under the cutter. So since I'm not going to move the Y-axis, I'm going to clamp that. I don't want that moving on its own. So now the Y is centered on the material is centered on the cutter. I'm going to raise the table up now until it touches the cutter. So let's get it close first. Okay, I'm about a 1/16 of an inch away. I don't want to touch a stationary cutter. Carbide inserts are very hard and they will break. So I'm going to put it in gear. I'm going to start the spindle. And always check your spindle rotation. Make sure it's going the right way so you're not going in reverse. It doesn't cut in reverse. So now while it's running, I'm actually going to raise up the table very slowly, just until it touches the material. Once it touches, I'm going to feed off to the end here where I can start. So it just barely touched it. You can see that it scratched it. So at this point now, I'm going to zero this. I'm going to loosen up that collar. I'm going to turn it to 0. And I'm going to go about, I don't know, let's go 20 thousandths. So I'm going to line that up with 20. Once I'm done moving Z, I'm going to clamp Z. I don't want Z to move while I'm machining either. Now you just simply feed across the material. If you feed too hard, you're going to have really rough finish in your material. If you feed too light, it's going to take a long time. To get a nice uniform finish while you're hand feeding, is to hand feed uniformly. Try to keep a nice, even, constant speed. Now there are feed rates associated with cutting steel as well. We calculated the speed on the spindle, but we didn't really talk about the feed rate under the cutter. So that was the first pass we took. Let me take a finish cut now. We're going to take another 5 thousandths, so it's going to go from 20 to 25. Reclamp Z. Now I'm going to take a finish pass. It's going to take a real light cut across there just to make sure we have everything machined nice. So I lowered the table before I bring the cutter back across the material because I don't want to drag the cutter across. If the cutter is turned off, you want to lower the table and move the material from under the table. So when you take the part out of your vise, you want to deburr these sharp edges. All the edges around the outside are sharp. So I'm going to take the file, I'm going to deburr those edges. Make sure that all the burr is off. Any burrs around here will make your part inaccurate when you put it back in your machine. So make sure you do a really good job of deburring these edges. Burrs act like high spots. If there's a high spot on your part, it won't sit straight in your machine. So make sure you remove all the burrs. So what you have now is one good machined face. This is precise, a nice finish, and it's smooth. So in order to keep track of this face, what I usually have my students do is either number it with a number 1 or put an arrow on the end, just so you know which one was the first face you milled. It's important to know that. So what I'm going to do now is put it back in the vise. I want to make sure that the vise is cleaned out. Take out your parallels. Make sure there's no dirt between the parallel and the vise. Make sure your vise is clean. Put your parallels back in. And then you want to put it with number 1 or the arrow against that back jaw. Now when you do this process, you want to make sure that only the back jaw is touching the material. If you close the vise like this right now, these two jaws are battling. This one wants to locate on the rough material. This one wants to locate on the finished side. So how to prevent that from happening is to use a round bar. They call it a bolster bar. It could be any piece of material you have as long as it's straight. So put the bolster bar in between your part and the movable vise jaw. So the bar goes by the movable jaw. The solid jaw, you leave it up against the part. What this does is it ensures that that part is going to square up against this jaw and not locate on the movable jaw. So you want to make sure that your part's up against the solid jaw. You're now ready to take the second pass. So you do the same thing. We're going to lower the table. I'm going to get underneath my cutter with the material. I'm going to start my machine. Then I'm going to raise it up just until it touches again. When it touches, you want to feed off to the end. You can raise your table 20 thousandths, but first we got to re-zero it again. And we're going to go 20 thousandths. We want to clamp Z and then feed across. So that was the rough pass. I'm going to go back to where I started and take a finish cut. Now you're probably wondering, why do I always start on this end? Why don't I start on the other end? The reason is, if you look at how the cutter rotates against the material, it's actually pushing the material up against that back jaw. We don't want to put any force on this movable jaw. We want the force to be on the back jaw. It makes more precise work. The other difference is, if you notice while I'm milling, the chips are flying away from me. If I was feeding the other way, those chips would be flying right at me. So this is the 5 thousandths finish pass here I'm taking on this side. Once I get to the end, I'm going to lower the table and come back to this side. I'm going to take out the part and deburr it. Turn off the machine, lower the table. Come back to the other end of the part where we started. The reason why I do this is so I don't forget. If I leave it over there, I might be not paying attention and then I'll end up cutting it the wrong way. I want to be able to cut with the, as the cutter rotates this way, you want to be able to push the material against this back jaw. Now once again, there's going to be burrs on your part, so be careful when you take it out. So I'm going to deburr it all the way around. Now that I have it deburred, you remember this number 1 side? We're going to put that back in. And this was the second side we milled. So maybe you want to label that one number 2. So we have a number 1 we did first, number 2 we did second, and we had the arrow on the end. So always keep number 1 up against this back jaw. So I'm going to take out my parallels again. Make sure there's no dirt on the parallels or no dust, anything. We want to make sure they're good and clean. Make sure there's no debris in your vise. Now we're going to put it back in, doing side 3. We did number 1 first, 2 second. So now 2 goes down, number 1 goes to the back. For this setup, we need that round bar again. Tighten your vise. We're going to put the workpiece under the cutter again, put the machine in gear and start it. Raise the table just until you touch. Go to the end. I'll re-zero this again. And I want to go about 20 thousandths again, just enough to clean up the rusty surface. After I move it, I'm going to clamp it. So this is my rough pass. Then I'll return back to the start point. I'll raise the table another 5 and take a finish pass. So after this finish pass, I'm going to take it out of the vise, I'm going to deburr it, and then we can start measuring it, checking it for squareness. off your machine. Unclamp your table, lower the table. Let's go back to our start point so we don't forget. Take your part out of the vise, deburr all the edges, and to help you keep track, if you want to number the third side, number 3, that's fine. And now to check this part for squareness, we can actually do that with a micrometer. Since we started with side number 1 against the back jaw when we did number 2, and we flipped it and did number 3, I should be able to check for parallelism between 2 and 3. There it says I'm 1 inch, 213, 213, 213, and 213. So by checking the 4 points between distances 2 and 3, you're able to verify that they are parallel, and then you know they are perpendicular to this first surface. So the last step would be mill the last face. You want to have all 4 sides perpendicular to each other.